G'day and welcome to another science lesson. It's Mr. Cockrell here. Can't wait to see you all in class tomorrow. It'll be great. So today we will be starting to talk about stability and reactivity, arguably the most important topic within chemistry. Cool. So elements have the same number of protons and electrons, making them neutral. We know that. However, they aren't necessarily stable. Okay? Even if we change the number of, even if we change the charge of some atoms, it doesn't necessarily make them stable. Depends on what happens. So let's look at lithium here as an example. So we know lithium has 3 protons due to the atomic number being 3. Therefore, we can assume it has 3 electrons. So we know the number of neutrons is the mass minus our protons. So mass is 7 minus 3, so we have 4 neutrons. So if we draw our diagram like this, we have our protons in the center, our neutrons in the center, and then we start to fill our electrons. So our first shell holds 2, so we put our 2 in, and then that means there's 1 left in the outermost shell, our valence shell. And so because there's 1 electron sitting by itself, it's not happy. It's unstable. And that's the key takeaway from this. That electrons aren't happy when they're not together. They don't have a pair, or when they're left alone. So, kind of like us humans, we want to have friends. So, electrons fill shells which correspond to the rows in the periodic table. We know that. So, we know that fluorine is in the second row, so it has 2 shells. So we know chlorine is in the third row of the periodic table, so it has 3 shells. So the first row has 2 atoms, therefore they fit 2 electrons. We know this. Second row has 8 atoms, so it can fit 8 electrons. But electrons which don't have a pair are unhappy, and the closer they are to having a full shell, the more unstable they are, because the more they want to be stable. So let's make this a bit clearer. If we're looking at anything in this first row, first column of the periodic table, everything here has 1 electron in its outermost shell. So it is really reactive. It's really unstable. Our second column here, they all want to give away 2. Now, so just remember that. Yes, we have 8 electrons to fill up 8 positions in our second and third shells, but they fill each position once each. So at the top, side, the bottom, and the other side, and then they start to pair up. So even until there's 4 electrons in it, it's still unstable. But then once they start to pair up, then they're happy, they're stable. But as we said before, the closer they are to having a full shell, the more reactive they are. So if we flip and we look at the other end, so fluorine here, fluorine has 2 electrons in the center and 7 around the next shell, in our second shell. It really wants to get this 1 because there's only 1 which is by itself. So let's relate this now to reactivity a little bit more. So it relates to an atom stability. So the more stable something is, the happier it is, therefore the less reactive. Now reactivity is really important because we need to know how we can use atoms to benefit us in real life. So on the other hand, if something is less stable, therefore it's more unstable, the more reactive it actually is. So I'll go through these 2 examples here again. So lithium has 3 protons, 3 electrons, 4 neutrons. It's only got 1 in the second shell, which makes it highly reactive. It would do anything to get rid of that electron. Fluorine has 1 position left, so it needs 1 electron to have a full outer shell, making it happy. So it would do anything to gain that 1 electron. So this is how stability relates directly to reactivity. If something is more reactive, if something is more stable, it is more reactive and often more volatile. It'll readily react. If you put those 2 things together, they'll react quickly and efficiently rather than taking a long time to react. Thank you, and we'll see you in class. Bye.
I just blew my mind.